Hi, I'm going to present you a case of calculus that uses the Fermat principle of refraction and equalize it with Snell's law. And well, the problem says the following thing. Let B1 be the velocity of light in air and B2 the velocity of light in water. According to Fermat's principle, a ray of light will travel from A to B into the water by a path ACB that minimizes the time taken. Shows that sine of theta 1 over divided sine of theta 2 is equal to velocity 1 divided velocity 2, which is known as Snell's law. We said that here we have two triangles for making the path ACB. The side below the first triangle I'm going to call it X and the other one Y. But we can say that ACX and the triangle BCY are right angles. And also we can say that theta is equal to X plus Y. That is the total distance, horizontal distance. The path AB is equal to the path from AC plus the path to BC or CB. That we can say that the triangles has a height 1 and a height 2. And we can say that the triangle that uses height 1 and the path AC and X, and the triangle which passes with the height 2 BC and Y are the right triangles in the problem. Using the Pythagorean theorem, we can say the following thing, that the AC is the hypotenuse, so it is equal to the square root of height 1 to the power of 2 plus x2 to the power of 2, and that CB is equal to the square root of height 2 to the power of 2 plus y to the power of 2. Now, we will try to solve the problem and say that theta is equal to x plus y, and so by isolating y we can say that y is equal to theta minus x. Then by using trigonometry we would say that CB, that is the path from the point C to point B, is equal to the square root of h to the power of 2 plus theta minus x to the power square, and AC is equal to h1 to the power of 2 plus x2 in the square root. Now, using the trigonometry, we will find which is the angle by using the sine, and we can say that the sine of theta 1, that is the angle up here, is equal to x over AC, and the sine of theta 2, that is the angle down, is y over CB. And after replacing, we can say that sine theta 1 is x over square root of h1 to the power 2 plus x squared, and that sine of theta 2 is x minus theta minus x over the square root of h2 to the power of 2 plus theta minus x squared. Now, for starting to solve the problem, we say that velocity is the total distance over the time, and in isolating time we can say that time is equal to AC plus CB, that is the total distance, over speed, that is b. Then replacing what we know, we say that time to x respect to x is equal to AC over b1 plus CB over b2, that are the speeds and total distance in each triangle. Then we have here t respect to x is equal to the square root of h1 to the square plus x to the square over b1 plus h2 square plus c minus x square over b2. That this will be our equation. Now, starting to differentiate, or the differentiation of the equation of t respect to x, or time, that we need to know. Having the previous equation, we say that this equation solved unsimplified will be like this. Then, for starting to differentiate, we use the product group and try to make the differentiation more easily. Well, with our first equation right here, t respect to x and t prime respect to x, we just simply use our previous variables simplified, that sine of theta 1 and sine of theta 2 with these values, and then we change it or replace it in the equation up there, or the derivative. In here we have that t prime x is equal to sine of theta 1 over b1 minus sine of theta 2 over b2. Then, finding the critical points that will show us the answer of the problem. We have our diagram with triangle 1 being this path from A to C, and triangle 2 from C to B. Then we say that the derivative of t respect to x is equalize it to 0, and so we have that sine of theta 1 over b1 minus c sine of theta 2 over b2 is equal to 0. Then we isolate the terms from each triangle separately, and we have this equation right down. Then we separate the signs and the velocities in just one part, in each side of the equation, And we will find that sine of theta 1 over sine of theta 2 is equal to b1 over sine of b1 over b2. And now we have solved our problem, because this is actually the Snell's law. And now we just have equalized the Fermat principle with Snell's law of refraction, and with this equation we will know when the path from A to C in the diagram will take less time by using this little equation right here. Thanks for all. This is my math project this year.